Horizontal stretch and compression. Given a function f of x, if we define a new function g of x as g of x equals f of kx, where k is a constant, then g of x is a horizontal stretch or compression of the function f of x. If k greater than 1, then the graph will be compressed by 1 over k. If 0 less than k less than 1, then the graph will be stretched by 1 over k. If k less than 0, then there will be combination of a horizontal stretch or compression with the horizontal reflection. Example 17. A function f of x is given as a table below. Create a table for the function g of x equals f of half x. The formula g of x equals f of half x tells us that the output values for g are the same as the output values for the function f at an input half the size. Notice that we don't have enough information to determine g of 2, since g of 2 equals f of half times 2 equals f of 1. And we do not have a value for f of 1 in our table. Our input values to g will need to be twice as large to get inputs for f that we can evaluate. For example, we can determine g of 4 since g of 4 equals f of half times 4 equals f of 2 equals 1. Since each input value has been doubled, the result is that the function g of x has been stretched horizontally by 2. Example 18. Two graphs are shown below. Relate the function g of x to f of x. The graph of g of x looks like the graph of f of x horizontally compressed. Since f of x ends at 6, 4, and g of x ends at 2, 4, we can see that the x values have been compressed by 1/3 because 6 times 1/3 equals 2. We might also notice that g of 2 equals f of 6 and g of 1 equals f of 3. Either way, we can describe this relationship as g of x equals f of 3x. This is a horizontal compression by 1/3. Notice that the coefficient needed for a horizontal stretch or compression is the reciprocal of the stretch or compression. To stretch the graph horizontally by 4, we need a coefficient of 1/4 in our function, f of 1/4 x. This means the input values must be 4 times larger to produce the same result, requiring the input to be larger, causing the horizontal stretching. Try it now. Write a formula for the toolkit square root function horizontally stretched by 3. It is useful to note that for most toolkit functions, a horizontal stretch or vertical stretch can be represented in other ways. For example, a horizontal compression of the function f of x equals x squared by half would result in a new function, g of x equals 2x squared, but this can also be written as g of x equals 4x squared. A vertical stretch of f of x by 4. When writing a formula for a transform toolkit, we only need to find one transformation that would produce the graph.